Auto transformer. A transformer in which a part of the winding is common to both the primary and secondary circuit is called an auto transformer. In an auto transformer, one single winding is used as a primary winding as well as secondary winding. But in two winding transformer, two different windings are used for primary and secondary purpose. General arrangement for auto transformer has been shown in this figure. This is actually a step down auto transformer. In this figure, AB is the primary winding of the auto transformer. BC is the secondary winding as the auto transformer. V1 is the applied voltage across the primary winding, and V2 is the induced voltage across the secondary of the auto transformer. I1 is the primary current flowing through the portion of the winding AC, and I2 is the current flowing in the secondary winding. And for the portion of the BC winding, BC portion, the current flowing is I1 minus I2. Since V1 is the applied voltage across the winding in between A and B, the voltage per turn ratio is equal to V1 by N1. Therefore, voltage across the portion BC of the winding, that is in the secondary portion, V2 is equal to V1 by N1 into V2 N2, that is the secondary voltage. Therefore, V2 by V1 is equal to N2 by N1 is equal to K. The copper saving in the auto transformer. The weight of conductor, copper or aluminum, for any winding depends upon the cross-sectional area and length of the conductor. Now, the conductor area is proportional to the current carrying by it, whereas the length of the conductor is in a winding is proportional to the number of turns of the winding. Thus, the weight of the conductor in a winding is proportional to the current and the number of turns in the winding. Therefore, as I1 current is flowing through the portion of the winding AC, the weight of the copper in the section AC proportional to the N1 minus N2 into I1. Similarly, weight of the copper in the portion of the winding BC will be N2 into I2 minus I1. Total weight of the copper in the winding of auto transformer proportional to N1 minus N2 into I1 plus N2 into I2 minus I1 is equal to N1 into I1 plus N2 into I2 minus 2 into N2 into I1. Since N1 into I1 is equal to N2 is equal to into I2, therefore equal to 2 into N1 I1 minus 2 N2 into I1, that will be equal to 2 into N1 I1 minus N2 I1. In similar way, it can be shown that the weight of the copper in the two winding transformer is proportional to N1 plus I1 plus N2 into I2, that equal to 2 into N1 into I1. Now let us assume WA and WTW are the weight of copper in auto transformer and two winding transformer respectively. Then WA by WTW equal to 2 into N1 minus 2 into N1 I1 minus into I1 by 2 N1 I1, that equal to 1 minus N2 by N1, that equal to 1 minus K. Here K is less than 1, that is equal to N2 by N1, that is WA is equal to WTW into 1 minus K, saving of copper equal to K into WTW. Advantages of using auto transformer. For transformer ratio is equal to 2, that is N2 by N1 equal to 0.5, the size of the auto transformer would be approximately 50% of the corresponding size of the two winding transformer. An auto transformer has higher efficiency than two winding transformer. This is because of the less ohmic loss and core loss due to reduction of transformer material. Auto transformer has better voltage regulation as voltage drop in resistance and reactance of the single winding is lesser.